Hello. So today we are going to do focus question F, which is the last main focus question that you have. We talked about previously how protons and neutrons are in the nucleus and electrons are in the space around the nucleus. So this last question is going to talk about where those electrons are located in that space around the nucleus, and then what happens if they change where they are. So the electron configuration tells us the address, basically, of the electrons. So if we were to look up on the reference table and we look up for sodium, sodium is number 11 on the table. So it has an atomic number of 11 protons, and then because it's neutral, 11 electrons, because the positive and negative have to be equal. And then if we look up the electron configuration, we see 2-8-1. And we've looked at this a little bit already, and we talked about how this was the shells that they were located in. So basically that would mean that if I have my nucleus, then I'm going to have two electrons in the first shell. I'm going to have 8 in the next shell. And then I'm going to have 1 in the outermost shell. And remember, it's not actually orbits like this. It's more of like a cloud or a region where they're located. Okay. So 2-8-1, 1 valence electron. So the ground state is its normal state. It's where it's most stable. And that would be something like we've got there, the 2-8-1. So that's going to be the ground state. It's the lower energy, and it's stable. Okay, so that's how the electrons exist on a normal basis. If we add energy, like heat or something like that, then the electrons get excited. And they jump to a higher level. So for example, if we had this sodium and it's normally 2-8-1, what might happen is one of these will jump up. And now my excited state would be 2-7-2. So the way you can see an excited state is when this shell isn't full, one of those has jumped up. So this would be the excited state for Na. Okay? And this excited state is unstable. Okay, they can't stay up in that higher energy level very long. So they jump up to there. It's very unstable, so they don't stay there very long. So what happens is when they drop back down, any of this extra energy they had in order to go up an energy level, because each energy level has more and more energy. So when it's excited and it jumps up to this higher energy level, it's unstable, it can't stay there, and it's going to fall back down. And when it falls back down, it's going to give off that extra energy in the form of light. Okay, so a bright line spectra is formed when excited electrons drop back down. So the light is given off when they drop back down, not when they're heated up and jump up. It's given off when they drop back down. Okay, so this is what the spectra look like. So here's the different wavelengths. So we range from 650 to 350. And hydrogen, for example, just gives these 2 little bands of light. And then these little groupings up here. Sodium just has these 2 bands. Neon has a wide range of bands down here. So different elements can be identified based on what their spectra look like. Okay, and we'll do a lab where we make these different flame colors when I get back. We'll do that on Tuesday. Okay. All right, so how do we answer questions about this? So if we look on the back side of this, we'll have some examples. Okay, but just to recap, our electron configuration tells us which energy levels or which orbitals the electrons are located in. This is what we call the stable ground state. Everything's in the lower energy levels. If we heat it up or add energy or light it on fire, then electrons are going to get excited and they're going to jump up to a higher energy level. So this 8, maybe one of those jumps up to the 3rd energy level. This is our excited state. It's very unstable, so they are eventually going to drop back down to the stable state of 2-8-1. When it drops back down, it's going to give off that extra energy in the form of light. And depending on how much energy it is what colors and how much light is given off, which helps us to identify the different materials. Okay? All right, so if we flip over to the back, so we're actually going to start with this one down at the bottom. So this is a Regents question. So we have element A that has these bands of light, element D that gives off these wavelengths, element Z that gives off these two. So this is a mixture, and we're trying to identify what elements make up this mixture. So what you would do is you would go ahead and run the colors of it. You'd see these different bands, and then you would look to a journal for knowns. So you would see what does it match up with. So you can see right here, the mixture has this. So Z must be part of the mixture. And then you match up other things. So we've got this band matching with this one, but we don't have this one. So it must not be A. This one matches with this one matches with this one, this one, this one, this one, this one. So Z and D are what make up that. And these would actually all be color. But unfortunately, we don't have a colored notebook. Okay. If you Google spectra, you'll be able to see. Okay, so this is what calcium's looks like. So this is going to be bands of like red, yellow, green, blue, purple. Red, yellow,